How did we work with random variables in univariate statistics? Well, we started by postulating different distributions for them. We had a rich collection of univariate distributions to choose from. Now, most of these came in families, individual members of the family being indexed by parameters, like normal 0, 1 and normal 1, 4. Both belong to the normal family with different values for the parameters mu and sigma. Now, if we try to use the same approach for multivariate statistics, we encounter a problem. For a long time, there simply were not enough mathematically manageable multivariate distributions. As a result, multivariate statistics proceeded in two ways. One, we just worked with only the few standard multivariate distributions that were available to us. This was rather restrictive. And two, we could apply ad hoc analytic methods without caring much about the underlying distribution. Most applied statisticians used this approach. Recently, however, we have found a very rich source of multivariate distributions using a concept called copula. This has opened up a third possibility which is rapidly gaining currency. In our elementary exposition, however, we shall focus more on the first type, touch lightly upon the second, and copulas will be left out completely. Whichever approach we take, there are some basic quantities that we must learn about. First, we need to know about mean. If we have p variables x1 to xp, then we may bunch them into a p-dimensional random vector x. Its mean or expectation is defined component-wise. That is, expected value of x is a p-dimensional vector. The first entry is expected value of x1, so on all the way up to expected value of xp. The sample mean is defined in a similar way in a component-wise fashion. If you have a data matrix, then you take mean of each column separately. There is a quick way to achieve this in R. Here I have a file, a data set stored in the file called data.csv. It is in CSV format. 3 variables and each has 3 cases. I want to compute the mean of all of them in one line. So first I load the data. My dat equals read.csv data.csv. When I do that, I can see my dat. I am of course using R, you understand that. So my dat has these 3 columns exactly as it should be. Now I can find out mean of each of the columns separately. For example, this line here can compute mean of the first column. So if I execute that, I get this 12.333, which is average of 12, 13 and 12. However, I do not want to repeat this command 3 times. Instead, I use this. I write apply, then the name of my data set. Then here I write mean. So I am applying mean. This is a function. I am applying the function mean to my data set. This mysterious 2 means I am applying it to the columns. Because it is a 2-dimensional thing, it has got rows, which is first dimension, and columns, which are the second dimension. I am applying it to the columns. So when I do that, I get average of x is this, average of y is this, and average of z is this. And just to show what's the effect of using 1 here, that will give me the row means, which is not that much useful. So now I get average of these things, followed by average of the second row, followed by average of the third row. In this way, you can use the function apply to apply another function mean to the columns or rows of a matrix. You could have replaced this mean by other things like sum or median or whatever.